Okay, so egal gave a good introduction. This is domain-specific language for validating structures in JSON. And the motivation was that at JanRain we had we used JSON for describing some user interface elements. And we wanted to make sure that when people passed in a configuration in this JSON structure that it had the right structure. And we thought we had a few things that we wanted to enforce. One is that error messages should be simple. We wanted writing validators to be intuitive, and we needed to be able to handle alternate patterns. And I'll give an example of that later, but imagine if you're representing something like an HTML tag, where it can be an input tag, a form tag, a div tag, or whatever. Each of these has different parameters that go with it. So in your JSON structure, you need to have, let's say, some key that says tag name, and then you have a bunch of different parameters. But which parameters are passed in depend on that tag name. So I looked at something called JSON schema that's out there, and it turns out, for one thing, it doesn't handle these kind of alternate patterns. It also looked a bit verbose to me. It wasn't very simple. I think of it as sideways. You have to say something is type as an object. And then you list its properties one by one, and for each property you have a key with the name of the property and a value that tells you what type it is and maybe if it's optional or all sorts of other features. That just seemed a little bit verbose to me, and I was looking for something simpler. The data I'm trying to match looks a lot like this. So in JSON there would be quotes around name and age, but this is an example from the DSL that I created. So you just take the quotes off of name and age and active, and to indicate something's optional, you've got this special optional keyword in front of it. And you've got type names instead of literal values. So one way of going about it was, one possibility I considered was using special objects to validate JSON. So for example, you'd say object validator new and pass it in string validators, numeric validators. Well, that's pretty awkward. Another option was to do the same sort of thing, but use convenience functions. And that's still, I still don't like that as much as what I wrote on the last page. So instead, we're using this structure that looks like JSON. If we're matching a literal JSON value, then our pattern looks almost identical to the JSON. And that was a goal of mine. Then, in order to validate, you call validation new from pattern and pass it in these patterns. And that creates a validation object, which you can then call validate from root on. I was influenced somewhat by regular expressions, because a regular expression, if you match literal text, it looks exactly like the text you're trying to match. And then there are special escape characters that tell you, I want to match an arbitrary character. So to match a type, you just put the, you can put a class name in, but each of these, so in JSON has nulls, booleans, strings, numbers, objects, and arrays. So on the right-hand side, you see the JSON name for things. On the left-hand side, you see a Ruby class name. It doesn't distinguish between integers and floats, but I thought that would be handy. And Ruby doesn't have a Boolean class, which is strange to me, but I put a dummy class in this library that doesn't actually do anything except use it as a stand-in for Boolean values. Then there are a few handy specialized types of strings you might like to match, URLs or emails. And if you have any kind of a regex you want to match, you just put the regex in that position. There's a special pattern called double underscore. It looks like a blank, and it means it matches anything. Now, matching arrays. You might think that then to match arrays, you would list the values in the array. But it turns out we didn't really have a need for that in our library, and I didn't find it to be a very common thing to have a sort of mixed bag in an array. Because normally for something like this, where you'd have a different type in each element of the array, you'd probably be using an object. But what we did have was arrays where you'd have a uniform pattern at each position in the array. So I made a notation for that. Array of string matches an array of strings. I reserved the notation at the top because I thought somebody will probably want that, and I don't want to use that for the bottom case. So extending that to objects, a common case with objects is, this is analogous to the array, the uniform array. You can have a uniform object that just has arbitrary key names, and the values are all match a particular pattern. Originally I called it object of, but I changed it to something more flexible. You can write many and a rocket. You can actually start out with particular keys that must be matched and follow that by many, and it just eats up all the rest of the keys. And actually, I want to pause for just a second and explain that JSON has some slightly different terminology than Ruby. What Ruby calls hashes, JSON calls objects. What Ruby calls, well, arrays are arrays. But within an object is considered to be an unordered list of members, and each member is a name-value pair. So what we call keys, they call names, and this is all just based on what it says on the JSON spec. So if you're getting confused by some of this, keep that in mind. So here's a fixed structure object. It has a name, an age, an active, and those are the types. Very simple, and just like a regex looks like a string, this looks like your JSON. If you have an optional key, you put optional rocket in front of it. Now you might be wondering, don't all my keys have to be distinct in Ruby? Can I write optional multiple times? Like, how can I do that? Well, that's because optional is actually a function which calls new on a class called optional key, and we'll see the code later. And it turns out you can have Ruby is very flexible about what you use as keys, so you can have arbitrary objects as keys, and each object hashes to a different value. So if I put optional in there multiple times, it's actually different key values. And the actual object is accessible through that. You can iterate through the hash and find the specific objects and see that they're of class optional key. So in this case, I'm making both age and active optional, and there's no clash between optional and optional. But there's a difference between that and writing optional rocket and grouping age and active together. That means that you either have neither age nor active, or you have both age and active. So that's something JSON schema doesn't handle. Now I talked about alternate patterns, a way of treating JSON structures like different subtypes, depending on a tag key or a tag value. That's something JSON schema can't do, and I would love to implement alternate patterns using pipes, but you can't overload that in Ruby.
Aging Marcus Roberts and his patch to provide this functionality.
That's hard because you have to pass through. The funny thing is, I'm chuckling. I've done something I want to show you afterwards.
Yeah, there's a very limited set of operators you can overload.
Yeah. But yeah, sorry, I didn't. Go.
No, it's okay.
Sorry.
Okay, so here's an example. We have some HTML tags. Tag name can be div, form, or input. And if it's a div, we also expect contents. If it's form, we expect method. If it's input, we expect all that other junk below that. Oh, there's also something in there called one of. That's the magical function which lets you specify alternate patterns. And so there's a simple example embedded in there where it says one of text radio button. And there's a more complex example at the top level. Okay, so here's an error that you might get from when you're using one of. Remember I said I wanted to keep the errors simple. So what's this dollar bracket tag name? Well, that's a JSON path notation. There's apparently two alternate JSON path notations, and that's the default one of the JSON path specification. So that's what I was using. Dollar means root of your JSON. So it found select, but it expected one of div, form, and input. So I tried to be as simple as possible with the error messages, no extraneous stuff, just when I got to this point, I expected one of these things, and I didn't find it. So here are alternate actions. In this case, we're using the key rather than the value to indicate which case it is. This is a little bit odder, but I bring it up because we were actually using this in our code. I mean, not this exactly like this, but something very similar to it. And here's an error. So it says found key pop-up, expected one of keys, call, email, redirect. Actually, I should have tweaked this because now it says found name pop-up, expected one of names, call, email, redirect, because of that terminology difference between JSON and Ruby. Sometimes you want to test a feature, but you don't care about unrelated errors. You don't want to see all. We had this problem where some people were working on part of the code, and some of the new stuff they were doing didn't validate, but they wanted to test. Or some of the new stuff somebody else put in didn't validate, but they wanted to test their stuff. So it's helpful to list multiple errors just like you would from a compiler. So it does handle that. In this case, it's just listing both errors. At the path tag name, it found select, it expected div, form, or input, and then at the root, it found a key it didn't expect. Okay, so there's some problems that come up with reporting error messages when you have non-determinism, these alternate cases. So the amount of non-determinism is restricted. What if you had a block where it said one of the above, as you can see, and we're missing what if we were missing the contents field? Well, is the contents field missing, or does that tell us we were just looking at the wrong case? Is the fact that the contents field is expected part of the dispatching the case, or so it's hard to figure out what kind of error message to show in that case. Should we tell them missing contents? Should we tell them expected, one of these cases and spit out all this garbage? So I decided to keep it simpler. It will only look at the first object member in the pattern. So it'll look at in other words, the first key value pair to decide which case to follow. And if none of those match, then it can give a much more concise error. Actually, specifically, it first looks at the keys, and then it looks at the values that go with those keys. And it's possible then that more than one case might match, in which case we get a ambiguity error. So here's another troublesome situation. And in this case, you're trying to say that this bar versus foo distinguishes these two cases from each other. And that's just too confusing to someone who's using this, who's using your JSON form. However, I have actually thought of a way, I'm actually kind of tempted to extend it to handle this. Because I think I can semantically make this particular case clear. I'm not sure that people have a lot of use for it, so I'm hesitant to do it for that reason. But I think that I worked out the semantics for this one to make the errors clear. Because it turns out as long as the error messages for the alternate cases are at the exact same path, then you can generate a simple error message. So in this case, we provided both keys, token and name. It expected one or the other. So what do we report? We say we expected token or name. Well, we got token and name, so that's not the problem. So instead, what it returns is an ambiguity error. It said, found keys, token, and name, but there were overlapping patterns, token, integer, and name, string. So it turns out that in order to simplify things, even if those patterns, integer and string, were much more complicated, or if it had like a literal, let's see, no, not if it had a literal value in there, but if it said token, colon, and then it had some kind of a hash structure, an object structure or an array, your error message wouldn't dump the entire thing. It would just say object. Yeah, so what if we wanted absolute full non-determinism? We run into a problem of how we can report the error. We have both first and second, so it's not clear which case to dispatch. So this is a good reason to just look at the first key-value pair. Now, handily, because we're doing this in Ruby, you can assign patterns to variables and then use them in multiple places. So maybe a name and a value looks like that, and then a pattern has a foo that points to a name and value and a bar that points to a name and value. You can also splice the object members into another object pattern. So we take name value and then splice it in using this members keyword. Those get flattened into the pattern so that they're at the same level. It turns out there are several operators which have that same effect. One of, there's another form of one of that uses a rocket that has that effect. Now suppose you want cyclic patterns that can match things like trees, hierarchical data structures. Turns out we needed that. So the notation for that is to write cyclic, and then you pass it a block that binds a variable that refers to the top level, and then you can refer back to itself. Where this says elements, that should say members, actually. But here we're using using deets. We're binding deets as the top level of our cycle, and then we're using it in multiple places. Yeah, you can also, if you don't want to use cyclic, you can also use assignment to create cycles in your patterns. Cyclic is just a convenience. So you can define a branch with the left and right initially nil, and then point them back at the pattern itself, and call new from pattern, and all the sharing structure, cyclic structures in the original pattern gets preserved in the validation. So some things that it doesn't handle. You can't validate that a number is in a particular range. You can't apply an arbitrary function to some point in your pattern and use it as a test. It doesn't report line numbers or column numbers and errors. It doesn't have any kind of notation for paths within patterns. So it has notation for paths within JSON that you're validating, but it doesn't have any notion for paths within patterns. It doesn't have any unique constraints. In other words, can't validate that if I have an array of objects and there's some field on the object, that field is unique within that array. And you can't have arbitrary expression constraints. I was just thinking of another thing a second ago that you can't do, but I could go on and on all the things you can't do. Oh, you can't, it's not a parser, so it doesn't return some set of objects to you or anything like that. It simply says either everything succeeded and you get an empty array, or it failed and you get an array filled with errors. And the errors are all, we saw error message in here. The errors are actually fully structured so that you can tease them apart and display them how you want them, but there's a default representation as a string.
Does it do regular expression matches for string?
Yes. So some related work that I looked at, we talked about JSON schema, and I beat on that a lot, perhaps unfairly. Something called Cerny schema, which does let you specify arbitrary functions. One of the reasons I didn't want to, I was hesitant to allow you to specify arbitrary functions to validate things, because I had in mind that you might want to serialize these validations, and in fact, currently they're fully serializable. So yeah, so I was hesitant to throw that away. Qualify is a lot like JSON schema, and then XML has a lot of different tools. DTDs, which are pretty much considered outdated by a lot of people. They're supposed to be replaced by the W3 XML schema, which is quite extensive and detailed and very verbose and has all these special tags for lots of different things. And I didn't want anything that complicated. Relax NG is really neat because it does have full non-determinism. But I haven't played with it. I wonder what kind of error messages you actually get out of it. And schematron is something that allows you to specify expression constraints using its own expression notation. So if I wanted to keep it serializable, I could invent some notation for expressions that's not just passing procs around or something. That's all for the presentation, but I'm happy to do a walkthrough on code.
Since approaching 9, maybe give an overview of some interesting portion of the test spec. Just get a feel for what it's like,
Sure.
and then give an overview of some interesting portions of the implementation.
Okay, so
I think it would make sense to go through the whole thing like we did.
No.
Maybe run this
Yeah. So this is up on GitHub, and it's also up on rubygems.org. So the gem is called JSON_patterns. So you can just pull the gem and start using it. Yeah, I have tests. The test suite isn't really fully comprehensive, but this is probably kind of small. Let's expand that. So the first thing that I'm testing is just the string representation of the output. And then I get on to testing the actual pattern matching.
You may want to read through one of those.
Yeah. Let's see. Should I pick a more complicated one?
Start with a simple one. So
Okay.
All similar patterns. Start with a simple one.
Right.
Those will be easier to understand.
Yeah, so we were actually using a slightly different testing framework, but I just converted it to test unit. And let's see. Okay, so literal string validation. If our pattern is this literal string, and then I make a new one from the pattern, and this is our value, and that validates, yay. But this is a different string, and so I get an error. And this is what our error structure looks like. It has a path that's just an array, says what it found, and says what it expected. If I give it an integer, well, it says it found an integer expected string. So it doesn't say found 4 expected XYZ. It's just trying to give the minimal amount of information to show you what's wrong. And these other ones for a while go on kind of like that with literals. Here's a regex match. And if you do get an error, it says what it is. It says expected string matching, and it prints out the regex. Whereas if it's an email, it says expected valid email rather than spitting out the entire gigantic regex for the email. The regex for emails and URLs is like, it's kind of ludicrously over the top comprehensive. Let's see, the uniform arrays. What I want to do with this testing is actually simplify this a little bit. There's patterns that I'm repeating over and over again, and I just need to make higher level testing functions for that. So if we have a value like this, then, and our pattern is array of string, well, that's not an array of string, it's an object, so it says found object expected array. Let's look at one of the more complicated tests down here. None of the tests are really complicated, it's just more advanced features. Oh, here's an optional disjunction. So disjunction meaning one of. So inside this pattern, we have a foo, then we optionally have one of these things. This is something that actually broke at some point, which is what motivated me to write this test and refactor some of the code. So it's really robust now with handling multiple nested levels of these keywords. Yeah. How big are the what? The patterns? Not huge. Connor, you've seen it, right? Like it's like 500 lines, or yeah, is it 1,000? Yeah, could be. Huh? Yeah, even with like nesting, yeah, nesting things and stuff. And let's see. So I actually did do a iterative test on this one, the optional disjunction, to test a bunch of different patterns. Oh, well, because there were 2 different patterns. Actually, unless people want to see more of the test, I don't think there's anything much more terribly interesting to look at in the test. I'd just like to show some of the implementation. Yeah. And is there anything else people want to see in the test, or no? Okay. Yeah. Lib. So yeah, I'm thinking of breaking this out to multiple modules, but right now it's kind of a big module. I did create some like tiny little helper modules because I wanted my object when I created them to just be able to pass a hash to new and to initialize everything from that. So I created this hash initialized module to let me do that. And then if anybody knows like stuff out there that does this already, so I don't have to like reinvent the wheel, it'd be nice. But and then this other deep equality thing just lets you test to objects of the same class to see if they're equal, deeply nested way. Inspectable is a thing that, so this is something I found absolutely crazy about Ruby, was that turns out if you override 2s, it automatically makes inspect do the same thing. Yeah. Well, if you create a new class and you call inspect, you get this very detailed looking thing. If you call it 2s, oh, well, I suppose you do get the same thing. And if you override 2s, it seems to be almost the other way around. Like normally 2s is calling inspect, but if you override 2s, inspect starts calling 2s. Yeah. So I'm like, well, darn it, I like this original behavior of inspect. So I wrote this module inspectable to replicate what inspect does. But I had to use some like thread local variables in order to make like cyclic stuff print out okay. So it handles it, prints out cyclic stuff exactly the same way inspect does when you haven't messed with it. So disjunction pattern is your one of, there's classes in here for each of the types of patterns, and then each of the keywords. So there's a whole section on patterns, and there's a section on validations. Do those really need to be completely separate? Not necessarily. I cleanly separated it so that everything that's pattern related, which simple things like integers and hashes are already patterns, but there's like special things like disjunctions and your special keywords that get added to that. And then when you call validation new from pattern, it transforms that structure completely into a validation. Didn't have to be done that way, but it just it was easier for me to make sure that everything was clean. I could have just written an interpreter that worked directly over the patterns, but it didn't seem as object-oriented either. So you see things like array of just calls uniform array pattern new. Here's our anything pattern, and you double underscores that. Here's an interesting bit about JSON types. So it knows which JSON type. There's actually a class called JSON type, and it knows which ones correspond to which values. There's a thing called shallow value, so that you don't give too much detail when you don't want to. Here's the validation failures. Different types of validation failures, 2 of them. And then validation, there's validation new from pattern. It actually has some memoizing, so when you go in cycles, it doesn't replicate its effort. It doesn't just get stuck in an infinite loop. And then the way I deal with the cycles is basically it just processes the very first level, and then it sticks that in the memoization cache, and then it starts processing the rest. So that if it sees the same thing it already saw, it just pulls it out of the cache. Let's see. There's some stuff to deal with. There's this equivalence where if you have some pattern that expects an object, some pattern that, there's a set of patterns which expect an object. And sometimes we want to treat those all the same way because in an object member context where you say like members rocket something or one of rocket something, on the right-hand side of that, for the value, you're allowed to put something that expects an object. but instead of treating it as an object, it gets flattened in and gets treated as object members. So we have to be able to know when the pattern expects an object, or the validation expects an object, but then treat it as a list of object members instead. So that's why that method is in there. I originally was transforming that stuff preemptively, but I realized later it was very difficult, if not impossible, to do that properly, and ended up doing that transformation on the fly. Let's see, we have object validations. Let's see if there's anything else terribly interesting. So the object validations, the object members validations are completely different. This class doesn't even inherit from object validation because it has different methods and returns different things. And there's methods in here like first value match, because it has to peak like sometimes at the first key or the first value. I was originally using continuations to do that, but decided it just looked too confusing. And then a sequence object member validations is just, one after another. I'm handling them as there's a left validation and a right validation, but I think it might be easier to deal with if it's just an array, so I'm probably going to change it to use an array. There's a special empty object members validation, and why you need that is just so that you can handle the case that you are expecting more stuff. No, that's not true. Actually, that's not true anymore. That was true in an older version of the code. Now it does that validation when it gets back. So if it's looking for an object and it says, oh yeah, that's an object. Now I want to look inside it and validate all the members. And then when it's done validating the members, it checks to see that there aren't any more. Optional. There's a cyclic validation. I have cyclic validations trying to do some stuff with like keeping, a count of how many there are so that when you display them, it uses a special notation, but I'm not really happy with that yet. Oh, there's our email validation regex. Should I paste it from somewhere on the web? And the URL validation. Yeah. And when you transform into a string, look, it's just URL. We have primitive types, primitive values, and anything. So that's all I have to show. But I'm interested to hear any questions that people might have.
So from what you started presenting this, I was thinking unit tests. When I have things that are returning based on, it's very frequent that I want to test one aspect of the result, and I don't want to test very frequently the change. So using this in-unit test.
Oh, using this in. Yeah, what he's saying is that. Yeah, what he was saying that he would have a use for using this in unit testing to validate that the results. In other words, you're testing something and you want to make sure that when it spits something back, that it's got the right form. That's interesting.
I only want to know one piece of the right, anything else can be.
Right. You're abstracting the results that are coming back and saying, I don't care what this text is as long as it's text.
Right.
Yeah.
And then I'll get a concise answer.
Yeah. Yeah, and that's cool. I hadn't thought of doing that. And we use this along with YAGL Ruby because you need something to parse the JSON into a Ruby data structure before you can pass it to this. And I chose YAGL because it gave the best error messages.
And he's fast.
Yeah, too.
Can you put this as well?
Yeah, I could probably do that. I was actually going to port it to Haskell, but then someone else at the company wrote some much more specific Haskell code to solve our problem. In other words, it wasn't a generic DSL, but it was a lot faster to write just specific code that parsed it into Haskell data structures. So we're actually not using this anymore. But one could extend the DSL to Haskell. It's just it was a fun process to design a DSL, and I found that Ruby. I was taking advantage of some very special Ruby things in designing this DSL, like the fact that this, unfortunately, don't throw too many things at me, that this is relying on Ruby 1.9, and it could be ported to Ruby 1.8, but one of the reasons it needs Ruby 1.9 is there's a guaranteed order to your hash elements, and so if I say, well, I would just want to take the first key value pair from the pattern and match it against the JSON. Well, there's no meaning to first unless your hashes are ordered. I mean, you could, of course, write it differently using like an array, but this is such a beautiful syntax that I didn't want to have to do that. So, any other questions? Do people have any thoughts of direction? Like, what would you like to see added to this? Or what would you like to see it do that it doesn't do?
Marcus, could you perhaps hop on a time machine and go back a month and a half and have this presentation before?
I did actually give the presentation a month and a half ago.
I missed it then. Really?
Yeah, wasn't it like 2 months ago?
Oh.
But I just haven't.
Oh, was that last one? No.
It was a PDX funk.
Well, it was at PDX Funk.
Oh.
Have
Because
you been writing your own equivalent?
very, very similar.
Darn.
In addition to one of, I have all of. And I handle optionally by
Okay.
Marcus,
Well, I might want to.
plug your laptop in and
Yeah,
use it?
plug it in.
Well, no,
Good.
but basically, it's very.
Oh, okay. I'll look at it afterwards.
Yeah.
I'm very interested.
But so yeah, it's. I definitely agree with the aesthetic though of having the regular expression having it look like what you're trying to match.
Right.
Because it makes it much easier to debug the expectations.
Right.
Because you're like, oh, it should look like this. Okay. So.
Right.
Yeah,
Right.
It's a cool. Yeah.
Okay. Thanks, everybody.
Yeah.